All right, guys. Welcome to the 2.1 notes. It's the first part of the notes. These will probably go over two videos. Yeah, probably two videos. So this is the first part of 2.1. And you guys have done the summer work, so you guys kind of see how this works. I kind of just display the notes, and I'm going to annotate. I'm going to write on these, and then I'll post this video to YouTube, and then you guys will have access to it through Canvas. As always, if you have questions, working from home, the biggest downside is going to be like I can't write on my screen, so it's like I'm writing with the mouse, which is not easy. So sometimes things may not look perfect. I'm going to try my best, but if you go through the video and you're like, oh, what does that look like? Like what number is that? Please let me know. Send me an email, shoot me a message, or whatever. We'll figure it out. So yeah, with that being said, let's get started here. So we're looking at talk about location here. That's going to be the kind of the big idea for this chapter is location and z-scores and percentiles. The reason why we look at this stuff is because different samples are going to have different distributions. And by distributions, I mean like the shape of the values, right? So when you guys do like histograms, right, or stem and leaf plots, like it shows here in the bottom, you can kind of see it on the page. Right, each sample you take is going to have its own distribution, right? So we need to find a way to compare distributions in a way that makes sense, right? So just because, let's say you're looking at class scores and Timmy gets a 85 on a test in his class and Sammy gets a 75 on a test, right? But maybe Sammy's class did significantly worse. Maybe their average was like a 60 versus Timmy's class, which might have had an average of like 75, right? So in comparison to their groups, right, comparison to their own distributions, right, we don't know which one did better. So that's why we do these percentiles and z-scores, right? They call it standardization, right? Is you're putting everything onto one standardized curve. And so then you can make these comparisons because up until then, you don't know what the distribution looks like, right? So that's kind of the idea, like why we're doing this, because we want to standardize our curves or standardize our distributions as much as we can. So with that being said, let's start here. Luckily, a lot of this is going to be text, so I can just use text boxes instead of me trying to write with the mouse. So first thing is what is a percentile? So the percentile, and we denote it with a P, okay, of a distribution is the value with P percent of observations less than that specific value. Okay, so what does that mean? If you're in the 80th percentile, right, 80% of the observations are below you. Okay, so that's kind of where this goes from. So all of you guys are upperclassmen. You've taken the ACT or ACT, whichever one, right? You get a percentile score. That's how many your percentage in comparison to the rest of the country or Dexter High School. And there's the percentage of scores that are below yours. Okay, so that's where this comes from. Okay. Scroll down here. So we have a stem leaf plot that shows the number of wins of each Major League Baseball team in a recent season. Okay, so we got these number of wins. Calculate and interpret the percentiles for the Colorado Rockies, which had 92 wins, and the New York Yankees who had 103 wins. Okay, so what we're looking at is we're looking at 92 wins, which is this thing right here, and 103 wins, which is this guy right here. Okay, so what are the percentiles for those people? Okay. Now the New York Yankee ones is going to be kind of interesting. Oh, and we want to look at the Cleveland Indians. That's 65. So where's that? 65. All right. So so the New York Yankee one is going to be interesting. The Cleveland Indian one is going to be interesting. The Colorado Rockies one is probably the simplest. I'm going to start there. So for the 92 wins, let me slide this down a little bit so I have some room. So if I were to count up the number of places it takes me to get to 92. So again, 92 is right here. Okay. So this is, so 92 wins equals the 25th place. Okay. If I just count this up, this is the 25th number. Okay. And so what does that mean? That means 24 teams had less than 92 wins. Okay. So dot, 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 well, how do we turn that into a percentile? Well, there's 30 teams total. So 24 divided by, oh, that's not 24. 24 divided by 30 is equal to 0.8, or in this case, 80th percentile. Okay, now let's keep going on. The next interesting one is going to be the New York Yankees that had 103 wins. 103, this is the last value. Okay, that's the last value. And so now, what does this mean? Well, you have, this is the 30th place, right? I'm counting up. And so 29 teams did worse than me, or did worse, had less than 103 wins. So dot, 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 29 out of 30 equals the 97th percentile. Okay. Now, this is where, like I told you guys, the difference between like what I do in my master's program versus what we do in this class, right, is that, and those of you that are taking calculus may understand this concept, or taking like an IBSL or something like that will understand this, right? This, when you think about percentiles, you think about it as a function, right? So this function is going to approach 1, right? Now, those of you that are taking calculus or taking pre-calc even, right, this is essentially taking a limit, okay? So if we want to apply it to other fields in math, right, we're taking the limit as n approaches infinity, and what that's going to approach to is 1. So if I take the summation of all these and I take it from n to infinity, that's going to equal 1 eventually. So that's why this is the 97th percentile and not the 100th percentile. Okay. So now, next one is 65 wins. And 65 wins is right here. Well, how many teams did worse than me, right? Again, I'm not looking at, I'm looking at strictly the teams that did worse than me. So how many teams did worse? I had 3 teams did worse, right? So, so this is technically 4th place. 3 teams had less than 65 wins, dot, dot, dot. So we have 3 out of 10, which is, or sorry, 3 out of 30, which is 1 out of 10, which is the 10th percentile. Okay. So again, percentile, you're looking at scores below below an observation. Okay. So how many observations were below 65? In this case, 3. Right. We have these 3 right here. Okay, so that's kind of a brief introduction into percentiles. Okay. So here is a cumulative frequency graph. Okay. And so cumulative meaning it adds all up, right? So you're going to keep building on itself. And showing the distribution of points scored per game for the 486 NBA players in 2016 and 2017. So Pau Gasol scored 12.4 points per game. So what is his percentile? And interpret that value. So what percentile is he at? So the way you can look at this graph here is 12.4. So here's 10, here's 15. So 12.5 is smack dab in the middle. So I'm just going to go as close to the middle as I can. And I'm going to draw a line up to the graph. It's about 12.4. Okay. And again, try and make that as straight as you can. And then I'm going to take this same thing at this point on the graph. I'm going to draw sideways to the percentile, to the percentiles. Okay. So now this value here on the graph, this represents 12.4 points per game, right? If I drop it down, you get to about 12.4 points per game. And if I bring it over, it's going to equate to, I had 75%. I mean, we're estimating here, so it doesn't have to be exact. But 75, 78, depending on how you drew your line. But I'm going to say here, this is approximately the 75th percentile. Okay. And again, using some of those vague words that I talked about in the summer work, right? It's not exactly 75. I can't look at that. But it's approximately 75 or 77. If you give some number like that, you'll be okay. Now, what does that mean? What does that represent? Well, this means that 75% of players averaged less than 12.4 points per game. Okay. Again, this is the percentage of values below a certain value or below a certain point. So it's the percentage of observations. So 75% of players, those are the number of observations, average less than 12.4 points per game. And again, I told you this in the summer work, right? AP is not going to, if you just said 75th percentile and left it, you're not going to get any points, right? You may get like half a point for getting the right answer, but the big thing is interpreting that value. Okay, we can do a similar thing on part B here, where it says, what is the 25th percentile for the distribution? So I can go in and draw some lines again, pick a different color. So 25th percentile, so here's 20, here's 30 on the graph, so 25 in the middle, something like that. Okay, and then drop it down. Okay, make it as straight as you can. And now the 25th percentile represents how many points per game? About 4.5, right? Somewhere in there, 4.5 points per game. So now I can go back in and answer the question of part B. I can say the 25th percentile represents 4.5 points per game. Okay, and again, there's some wiggle room there. And let me do this. Approximately 4.5 points per game. Okay, so again, just because we're not, we're approximating here, right? We're just giving some general solution. So if you said 4 points per game, that's fine. If you said 5, I would probably give you incorrect, because if you look at 5, it brings it up to this little diamond on the graph. So that's probably a little too high. That's about 31%. Like, between 4 and 4.75, somewhere in there, probably fine. Okay, and now, is there another name for this value, the 25th percentile? The 25th percentile is also known as the first quartile, or in symbolic form, T1. Okay. Quartile meaning we divide the whole group into quarters, so 25th, 50, 75, and then 100. So that's where that comes from. And quartiles are going to be pretty important here as we go along. And you guys see, I've seen it with box Mischke plots as well. All right. Make a relative frequency histogram of these data. Can I? All right. Let's see. All right. So I'm going to make a little table here. I was hoping that Zoom could make tables for me, but it can't. But that's okay. So I'm going to make a little table here. And you're going to see why I'm doing this here in a second. So this first column is going to be points per game. I'm going to make a histogram out of these. Second column is going to be cumulative. Relative frequency. Okay. And then the last one here is going to be relative frequency. Okay. And I'm going to show you, I'm going to set this up, but I'm not going to go through the whole thing because it just takes a little bit too long. And there's no point in doing all that. You'll get the point pretty soon here. So what I'm going to do is I'm going to look at my graph. So I'm going to scroll back up here real quick. So I'm going to look at my graph, and I'm going to break this down into some bins, right? So what I'm going to do is I'm going to make my first bin go from, let's see. I'm going to make my first bin go from 0 to 5, okay? Now, when I do this symbol, means it's included. Those of you that are taking some of the higher up math classes will know this. Okay, and then when I do an open parenthesis, so either that or this means included. If it's just like a regular parenthesis, it means not included. Okay, that's where the symbols come from. Okay, and you're going to see why I'm doing that here in a second. So we'll go from 0 to 5, but not including 5. So that's going to be like 4.9999999, right? And so that cumulative frequency, if I go back up to the graph, right? So from 0 to 4.99999, that's basically 30%. Okay, basically 30% of my data is going to be there. So it's just 30%. Okay, and then relative frequency is still just 30%. Okay. Now my next group is going to start at 5, so it's going to include 5 and go all the way to 10, but not including 10. Okay, so it's going to go from 5 all the way to 9.9999999. And so now that cumulative frequency, if I go back up to the graph, well, if I look at just below 10, I'm at essentially 70%. I'm going to call that 70% for the purposes of this. Okay, so my cumulative frequency is 70%. Now to determine the relative frequency, all I have to do is look at the difference between these two numbers. Okay, so basically what this is saying is that from 0 to 5, I had 30% of my data. From 5 to 10, right, I had 40% of my data. Right, and what does cumulative mean again? It means addition, right? So basically when you put these together, I get back to this over here. 30 plus 40 is 70. Okay, I'll do one more, and then you guys can kind of do the rest on your own. But what's going to happen is that the next one, we're going to go from 10 to 15. 15 is going to be at 80. I put 88% on my notes. So put that in. So we have, so we're going to include 10 now. So we're going from 10 to 15, but not including 15. So that's 14.99999. And that's 88%. And so what's the relative? That's the cumulative is 88%. So what's the relative frequency? That is 18%. And you're like, well, what's the point of making this giant table? I'm going to show you here in a second. So get rid of some of this stuff. So now if I want to turn this into a histogram, it works out pretty easily now. So I can draw some axes. Okay, and then I show you. Okay, and then here is my vertical axis. Oops, gone the wrong way. Right, and then I can label these. I can label my x-axis. Got the 0, starting at 0. We're going to 5. Then we're going to 10, 15, and then so on and so forth. You can kind of keep doing this as you go along. Okay, and then here is relative frequency. So I'm going to label my axis, the relative frequency. This is the x-axis is points per game. So I want to make sure I label everything. I'm going to come up with some title. This is histogram for points per game for NBA players. Okay, and now I can go back in and I can start drawing. So now from 0 to 5, I'm going to label this 10%. The highest relative frequency is 40%, so 10, 20, 30, 40. All right, so now from 0 to 5, we had 30% relative frequency. So we have a lot of graph like that. That's pretty bad. So we have a little histogram like this. And then the next one, we go relative frequency is 40%. So then we have something like this. And the next one, we had 18%. See something like this. And then if you kept going, you would have got 4%. These kind of just keep getting smaller and smaller as you go across here. So you have a histogram looks end up looks something like this, right? And so now, again, going back to this unit 1 stuff, which is why the unit 1 was kind of important. How do we describe this? But right away, I can see this, and it's a right skewed distribution. Let me change the color of that. We have a right skewed distribution. So what do we know? The mean points per game is going to be higher than the median. Okay, the median will be a better estimator for points per game, and we can kind of talk about some stuff like that. So that's why this stuff in Unit 1 is pretty important. Is we can start describing histograms and make stuff like this. Okay, so that's the first part of the video, guys. In the second part of the video for 2.1, I'm going to go over z-scores. So if you have any questions on this stuff, please let me know. If not, have a great rest of your day.